Okay, before we continue to the videos, I'd like to show you about how many the videos that actually provided in the workshop. So I'm gonna switch to the screen for a moment, and these are the list actually of the video that you can see. Actually, we have like a 14 of them, and all of this gonna be uploaded in the YouTube playlist, and it's accessible for you for having a practice and listening or seeing them in your own time. So go back to the environment demonstrations, which is video 001. Let's go to the link. I'm into the list. This is the list, so we can play this video for the 001. I will make a briefing explanations about what is going on in each videos and regarding to each chapter. So please bear with quick explanations, so you can see them slowly in the YouTube afterwards. Well, if you click the video, it will run like this. So the first video is having a good explanation about how you should set up your environments, and it's starting from the Linux first and then goes to the Windows afterwards. And this is quite important basics for all of the analysis that you're gonna do with radare for the shellcodes. It is quite a comprehensive explanations, and it has many samples. We are using this Surigi Linux for the Linux, and for the Windows, these are the setups that needed to be implemented into your systems. And then after that, explanations of one by one about how the stuff that needed to be set up, and then started with the Linux setting up, and it has many files, many kind of a template that you can use for making a shellcode. Several examples about how to test the environment too is provided in there, and these are the hint that is actually needed for you to make a shellcode running. It is having a good English explanation slowly in there, and this example about how to test the environments, and after that how to test it like that with for example in the S-trace or and so on. And then we are having also another kind of the setup, and this is another test for the ELF with assembly ones, and we can start it also. We are studying about the differences between the setting up for the testing shellcode in the using C wrapper or assembly wrapper. So you will know the differences, and how to set up your system will be explained afterwards, and the requirement that needed to setting up in the Linux is listed over there. And starting to basic about how to view the shellcode and to recognize the locations of the shellcode in the testing binaries for any kind of shellcode that you'd like to test will be explained in this part. And we can also compare about the source code to the radare shell over there too. And also we'll see about the many kind of this stuff afterwards. And for the Windows part, we are switching to the GUI and then going to the shell environment of the Windows because of the font is quite bigger. So I'm gonna use this environment for all over the workshop, mostly, but sometimes you have to bear with the folder kind of the viewing. And yes, we are using this kind of tools. This very good one, R-Windows-C, and we are using also the code blocks for the beginner to know about how to compile this shellcode in the C wrapper. And then this is R-Win-C demonstrations, and we are having the special template to compile the shellcode in the assembly types to make executables be for the analyzing any kind of the shellcode for the 32 bits, and some testings after being compiled will be presented in there, and also how to set up the radare as a software. In this demonstration, I'm gonna use the 5.3.1 stable one, and explanation about that too, and how to execute them, how to analyze the first for the first timer, how to figure where is the shellcode testing that will be implemented in there, and how to debug it, which is very comfortable for you to try if you are new with radare and just depending on the Windows environment, for example. And this actually the code and so on, and these are the several files being demonstrated. In this case, I'm using the process hacker to make sure whether the connections or the program is actually started or stopping or crash or something like that. And well, this is all about the first video, and in the end there's an explanation about the very good old tool Dumbin that can be used to study about the Windows libraries and to understand where is actually the export address. In this case, you can seek where the RVA or ordinals and the name of the functions API that can be seek. This is actually a base know-how that if you want to dig further to the Windows shellcodes. So that's gonna be it for the first demonstrations. Let's go to the next demonstrations. Okay, now we are finished with the presenting of the environment, so we want to try to build the shellcode by ourselves. In this chapter, we will start with either Linux or Windows first. Then we will use those operating systems for making first shellcode that actually becoming a good challenges for the beginners. In this environment is 32 bits for each operating systems. And in the Windows, we will try to access any kind of the API that available to be called with the absolute address. And after we are doing that for the Linux and for also the Windows, we will switch further to the Windows because of it needs about the know-how on the how about you are using the API for making any kind of the library to be loaded and to use that loaded libraries API for any kind of use. So in this case, I'm introducing you about how to make a message box. A message box is quite not as easy as we thought because of it'll need you to loading several libraries needed to make the message box A, for example, to be called. And you have to learn about how to make a plan for as per described before. For example, in order to make the message box, you will need to know about the where the message box is located, and in order to do that, you have to make a plan of it. We know that there are message box A, message box W, and we are seeking for the message box A, which is the API that actually resides in the user32 DLL, and user32 DLL is not actually loaded when the any kind of the application is running. So firstly, we'll load the NT DLL, and then we'll load the kernel base and the kernel 32 DLL, and then how it will explain how to get there and fetching this API inside of the user32 DLL. And for that, in this example, I'm going to use strings seeking methods in order to get us to the user 32 DLL. So we are using user 32 DLL. It will be pushed to the stack first, and then will be saved in the register, and then afterwards we will use the kernel 32DLL, which is actually already loaded into the init mode start when the actually application is running in the 32 bits in the Windows. Doesn't matter whether your system is 32 bits or 64 bits, kernel 32DLL will recognize if you are running something with a 32 bits, it will be loaded. And inside of the kernel 32DLL, it has the API of the load library A, and then you can use the load library A to load the user 32DLL, and using that with manipulations of the registers, and then afterward you can seek invoke the message box A with get process address 32DLL, and to get the user 32DLL's API message box A, and then afterwards you save another kind of the strings that you want to pop up in the message box, and then after everything is set and executables is needed for running the message box A is already in the desired registers, and all you have to do is just execute the message box with the arguments that already pushed in the stacks. So afterwards we can use the know-how that we did before over here, the absolute address, which we can use that for invoking the exit process in the kernel 32DLL to finish the process. So this is planned. To make it simpler and easy to understand, this is a pseudo code for the C code for that plan itself. In this way, probably some of the you who's involved with the development will know exactly about what we are talking about. So we try to use this, and we try to execute the message box A or W with the get process address, invoking the user 32 and loading the message box. We will load these strings to pop up, and hopefully it will result in stuff like this. So this is planned, and it seems doable. So how about to make this as the shellcode? It will be explained in the next demonstration. So here are the stuff that needed to be done, and there's a video for it, and we'll go to the video right away. I will make again brief explanations about that, and you have to see the video by yourself, and you have to follow the steps over there and doing it for the exercise. Okay, first we are going to see the video number 002 explaining about the absolute address calling for Windows and Linux. We go to this shell environment and run the video number 2 here. So here we are. We're starting the explanation first with the how to make a message printing messages in the Linux environment, and we try to make a simple printf, and this is the result after being compiled, and we study about how this opcode can be made into a shellcode or not. And afterward, if you're thinking that it's not possible, we just going to the next method, for example, using this a little bit more to the closer to the kernel stuff, like fwrite or flush, for example, that can invoking more library like functions. And we will compile it again, and we will see about the result. And then after the alpha being made, we can see that analyze that oh, this is still including some stuff of library outside of the scope that really need to be loaded. It's not quite good. Then we go to the next stuff, which is performing the syscall for the writing functions, and let's see about the result afterwards. And we compile it pretty well with a template and the hint that was explained before in the how to make environment, and then we study about what the result in it, and then we seek that the opcodes is there, and then probably we can do a little bit more changes. For example, the database settings has to be more implemented in the actual closer to the program, so it can be made more compact and small and fit to the criteria of the cell codes. And in the end, we will have to dwell with the assembly language for that. And these are the how the explanation about the how to make of it. And this is actually based on the what we did before with the right syscall, and then now we just rewrite it again in the assembly forms, and we compile it, and then we will see about how the result will be. And this is actually the template that being used in the NetWide assembly compiler, and we check about the result of these assembly programs, and we can see now this is actually the cell code. Stuff like this is being made and being trained for you to understand about the how actually to build a cell code is, and what kind of the challenges that actually happen, and so on. And you can check whether the cell code is actually working with the emulations, and then we can there is an explanation about how it can work and how it cannot be analyzed through the ASIL or emulations. And there's also several tips for the easy debugging for this purpose. Well, this is actually the way for the compiling it as a cell code after being decided this is actually the hex code that actually needed to make it as a cell code. And then first compiled with a C program, and let's see whether it is working. This is the way to build the hex strings that can be used for this C compiler, and then using that in the kind of the wrapper, and using the hint command over here that wasn't explained before in the build environment, because of this is related to the building of the cell code itself. And after you compile with these options, and then you just copy paste and change the necessary stuff, and actually the file will be made just like that. And then you can check, and you can seek whether the cell code is there, and you can find out where is the object cell code itself. And it is done with the C wrapper. And then let's dig it further also to the Windows environment. So in the Windows environment, you have to do the most more or less similar stuff with the Windows 1. You have to use several templates that has been provided. In this matter, I'm going to use the assembly template for the compiler and the C wrapper too. So if you want to print the hello in the message box with C programming in the Windows, is quite easy. Demonstrated from that first. But then we will find it is actually difficult to call directly to the message box, because of after several guided investigation will show you the POC that actually the needed user 32DL is not actually being loaded to the memory. And then this is actually how to seek the memory with the radare. And then you can having the understanding about what is the things that can be seen and cannot be seen during the debugging on the Windows in the radare environments. And after that, you will see about the result about the compilations that you made before, to see actually that the desired functions is actually the imported libraries. And after that, you can see that this is a message box A being used, and you will have to load that to the binary. So it's not very good to do the message box for the learning about the building the cell code from the scratch. So we will use a another kind of the method, which is actually being more easily to make as a shellcode. And in this part, we are trying to pick up several functions in here, like exit process, for example, and sleep. So we can use only the kernel's 32 DLL, and we just try to compile it, and then we just try to get the absolute address of those tools APIs are, and we plan about how to make it executable with a shellcode under the assembly languages. Just write it from the scratch, stuff like that. And let's see whether it can be a sleep and exit process being implemented by putting the absolute address that we seek before with the RVNC, and then let's see whether it can be executed or not. And it has some explanations about this is absolute address is only run on only one time, probably if you are restarting against the operating system, and then the absolute addresses will be changed and so on. So it has a merit and demerit in using the absolute address. And some testing about how to make that, and this is actually the program itself after being compiled, and we are seeking about what the shellcode is actually being coded afterwards, and we try to build that shellcode based on the opcodes that have been compiled in the Windows environment, and we made C code templates, and we are making the assembly codes templates too, that can be used for the wrapper on the compilation and testing the shellcode. This is the wrapper that being used, and we just try to compile that afterwards. And this is for the assembly one, so we have the two stuff that are being prepared, and then afterward we try to compile them one by one. The C starting from the C first, and then we go also with the assembly afterwards. Most of them will be done and will be tested in the process hacker, because of we are just running the program which is only going to sleep and then exit, and both of the result will be tested. And this is actually the first shellcode that you can practice to make in this session. It's quite easy, it's quite entertaining. The point is not making you about the super massive shellcode in this first try, but try to make you being close with the radar environment and the shell environment that actually can make you operate quite well too over there, especially for the beginners. So these are actually the shellcode that being made, and then as you can see, there are differences with the compilations resulted from the net-wide assembly and C compilers, which is based on the GCCs. Mean GW is a GCCs. So there, it is actually what the presentation is all about for the building the shellcode. But yet we are still seeking how to make a message box, right, in the first place, so in the Windows. So we know about how to make it absolute quotes, but what if we want to use another library which is having another API inside that library to make a easy shellcode like a message box? Is there any way to do that? Yes, there is. And then in the next video, which is explained in the, let's go to the slide in here. This is actually the first way to make you use another kind of the library in the Windows and use the API inside of it. And the demonstration for that is gonna be the file 003. File 003 is this file, so I'm gonna run it right now. So as per explained in the plan, that in this video I will explain about how the easiest way to get you the desired libraries using the absolute calling methods. And in this case, we are using the load library ACE, which is will be called through the absolute address, and afterward we are using the exit process 2, and then many of them are using the absolute address calling, and how to get the strings to the stacks first, and then afterward you can try to get any kind of the functions names which is can match you to the desired API to execute the desired operations. In this case, is a message box A for the executing a message box messages, and how to manipulate all of the data to the stack and goes to the some register for the further usage as a registers. So this is it will be this is gonna be your first assembly program for the cell coding if you never making a cell code before. So I'll try to make a very thorough explanations about that this matter, and by following these videos and understanding about what this actually being done, this is actually the very basic ways that you can make a cell code from, and probably in every system the absolute address is not the same, so you have to really check your current existing absolute address, and then you have to compile that again to make it works. And I guarantee you this is all work in the Windows, even Windows 10. And after doing this, we will start to testing and making about the explanation on how to actually compile those, and then we try to go to the some operations in the radare, which make you understand about how to see the stuff that being compiled after being compiled. For example, if you are actually go to the binary after being compiled in the ELF mode on the Windows system, you can make you can see a very beautiful code that actually being intact and imported as a flag in the radar that can be used for your analysis or any kind of the manipulation of the cell codes later on. And there are some ways to for you to browse the actually binary after being compiled, and to understand about which place actually the cell code will be implemented after you compile it in the Windows platforms, and then how to make that if after being compiled to be a cell code, like previously explained. Also, like this, you can use any kind of the hex header to do so, and then afterwards using that binary hex in text, you can use it in the any kind of a template that provided. Use the assembly one, and use the this is a C code to be used in the C templates, and you just build it. It was built and tested. It is pop up there. Stuff like this is being explained in this video. So for the assembly one, this is a way to compile it, and then the same things happen, and then after you execute that, the result of the compilations, it will be executed there. And we changed the name of the executables with to make sure this is actually the result of binary compiled from the assembly templates, and then if being executed again, it will be run as per it is, like that. So all are working pretty well. So you can use this as a cell codings, buildings, or analyzing or regenerations in the any environments related to the 32 bits. And there are some examples about that in the Windows, and then also some examples about that in the Linux platforms too. So let's go back to the training brief presentations, so we can go to the next part. Okay, here we are. Let's go to the slide then. Yes, Now it's about the analysis techniques in radare2. Well, practice makes perfect. I like this very much. And here we go. So these are the stuff that you really need to know about how to make a analysis in radare for the shell codes that you are facing. First, there are three types of the analysis that can be done in the radare2, which are static analysis, dynamic analysis, and emulation analysis. So static analysis is can be done after you understand about how to build a shellcode, and probably you want to make some kind of the testing for that. And you can also directly to analyze the payloads to seek what the actual operations this shellcode will be, and after that you can deal with adjustments in your systems for making sure about some emulation calculations, for example, or some kind of the patching that you want to make sure that the shellcode is doing some kind of the operations with io.cache. io.cache is one environment setting in the radar that making you to not making changes in the binary that you are analyzing, but try to make a temporary space for making any kind of modification, so you are not messed directly with the binary you are investigating. And there is a practical shellcode analysis in radare with a dynamic analysis, which is reconstruct the executables, and you can load it by yourself. This can be done after you regenerate the shellcode with any kind of a wrapper that you already provided, and try to run it. And then after you analyze it, first you have to make sure it is going to be in a very safe environment, and you have to analyze it statically first into a limit that you can do it, and you just confirm about those operations or the stuff that you don't really make sure about with this dynamic analysis. It is also called as debugging, and this is where actually you will recognize how the payload actually executed. For the practical shellcode dynamic analysis, the most important ones is I'm doing the DFIR a lot. So in my case, I try to simulate the shellcode, for example, not only to confirm but the operational executions of the shellcode itself, but actually the artifacts that can be generated, and what kind of the log that can be triggered to make sure that this shellcode is actually leaving a trace or occupying which kind of the space in the memory and stuff like that, which gonna be a good reference for the investigations as reference. And emulations analysis is the usage of the emulator in the radare. It has a very small virtual machines, and it has a very good logic made by the Conrad. It is called as EASIL. EASIL is emulations analysis in radare, and then it can be used with you have to generate the ASIL in the environment to make sure about the ASIL calculations can be performed, and then you can also making about the actual stepping, for example, to make sure about some fake register can be used for calculating any kind of the operations, and you can initiate and you can reinitiate the ASIL afterwards too. These are some operations that actually can be used for the ASILs, or some operations that can manipulate the strings that can be used in the radare. So two ways. If you want to use the W command like this, we have a WO series, which is for stepping and so on. Not stepping. This is for subtractions, additional, and so on. And these operations can be used for checking about the values or the binaries that they being investigated without messing the real binary, if you are using the IO cache. If you are using the ASIL, it will not touch the the original binary or the original environment at all, and the radar will use a fake stack for that, and everything will go to the VM environment for doing any kind of the operations. So these are the big difference between these two. Please be careful about that. Analyzing Windows and Linux shellcodes in radar is different, but practically it is different because of the operating systems is different, and any kind of the tools that you want to analyze Linux in Windows, it has some generic differences. In Linux, invoking syscall can be easily spotted because it will trigger any kind of this syscall wrapper or the interrupt that is needed to start the execution of the syscall or the service 0, and we can understand. We need to know know-how about how to seek the syscalls are being used and stuff like that. Radar is having an implementation of some several basics libraries of the syscalls in the database, but you have to also improve yourself also to get much more libraries that can be implemented for your operations. So there are many targets for analyzing in the Linux. It is quite easier than Windows actually, and you can analyze a thread or process, loader, libraries, or kernel, anything that actually running into your systems, but probably you will bump with several boundaries that not allowing you to make some changes, but you can make some adjustment for that. And for that purpose, you have to use the VM for running those kind of the Linux distributions which you want to experiment with. And for the Windows operating systems, and for Windows operating systems, you don't have a direct kernel interface, right? So you have to make sure that you really need to aim the address that they actually invoked for running certain API that actually being used for the shellcode after somehow there were some kind of the operations to load the DLL or libraries like that. And well, mostly most of the shellcode are using the load library A to load libraries, and probably get the proc address for the APIs being used also for executing some libraries, and WinExec, for example, is being used a lot, and for the any kind of the operations related to the network, probably the library like WS32 being used, or probably another library also can be used for the purpose. And mostly in the any kind of the operations, these are actually not much difference with Linux. Function arguments are really safe in the stacks and passed to the registers according to the their API usage conventions in the Windows platform, or in Linux. You have to understand about how the syscall or the functions related to such operations will be called. So you have to work very close with documentation for both kind of the usage of the arguments or stuff really needed to run functions. And for that, you have to very careful also about the usage of the register. And then there are in the complex shellcodes, mostly they are built as the modular in many functions, so it has a separate in several modules actually, and then they are calling each other, and then there are so many arguments being passed over there. So, and for executions, probably they are those kind of shellcodes are using EX or RUX for the executions, or probably EBX, RBX, whatever, and then you have to really know about those kind of the trend, and then if you are digging it further to the advanced class in the many kind of the modular shellcode analysis, you will see a very significant pattern about some executions that can be performed by a specific shellcodes and can be traced from there too. The challenge is mostly R2 static analysis for Windows is being hard with dealing with the obfuscations or some simple cryptographies operations, like mostly use are XOR or AND or RAR kind of the operations. And Linux shellcode analyzed in the R2 is well, mostly shellcode are analyzed in the VM environment, right? So in anyway, if the attackers knows that the payload is not running in the VM, probably there is a possibility also that the shellcode is having a simple checking for whether the victim is running VM or not, to avoid the kind of the analysis and so on. Those are the challenges. And for that, we go to the next static and dynamic analysis for the Windows in demonstrations. In these demonstrations, you will refer to the video number 004, and we will see it soon. So in the next demonstrations, it's about the mystery shellcode binary, which is actually being used for this practice for the static and the dynamic analysis in the Windows 32 bits. And this is quite interesting for testing your analysis process or logic in using the radare2. And for that, we are using the video in the list number 004. We will start like this and explaining you about the binary in there. This is actually the binary that needed to be dissected here, 003 mystery-ac.bin. So the mystery is quite good, practically explaining you about some shellcode over there that needing to be analyzed, and you have to grab the opcodes first, and then you have to seek how to read the inside of the opcodes and disassembled codes and try to figure how it works, and step by step about how to nail the bug in the radare will be performed in the videos. And then afterwards you analyze that and dump the result into the text file here, and afterwards you will be guided to make analyzing for the text files. The text files will look like this after being done, and I was just writing all of the analysis result in there, so stuff like that. And then you will be guided thoroughly until the you know exactly what the steps of the shellcode is doing. So it is practically, the shellcode is quite interesting because of it will pop you the message box with wood messages, and it's a Windows shellcode seeking for the API by loop, and the first loop is try to seek the hash of the load library A in the kernel base.dll, and it uses the load library A to load the user 32 DLL afterwards, and then seek the hash of the message box A, and then break the loops for the searching and seeking after you found those two library being loaded, and then the two APIs already known. And after breaking the loop, pushing the actually strings needed to be used in the message box and into the stacks, and executing the message box A arguments. This is quite simple, and it's quite interesting. It is straightforward, and it's actually becoming a very good reference for you for the dissecting the more shellcode after this. And the presentations in the videos is quite details, so I'm gonna skip several parts, and it's including how about analysis being made in a statically way, and then afterwards you have to making some how to running it to debug it, and then it will guide you step by step about how to analyzing it through the wrapper, and you compile it like that. And all of the stuff needed is providing to you in the actually folder that being uploaded in the internet. And these are the files that you will actually being seen in the saved in the folder that in the Google Drive, so you can play with it later on. And well, afterwards you just try to compile it to make sure that it is running or not running. And then there are many ways for you to test this binary or that kind of the strings to run in the environments that you are compiling with, to know exactly what it is doing. And afterwards you can just try to learn to doing the dynamic analyzing, how to execute the program after being loaded in the debugging state of the radar array afterwards. And then there are several tips that can be done. In this case, you can make sure whether the program is really using the kernel base .dir and not the kernel 32 DAL. Well, it is quite simple, because of the EBP is will point to the which library that actually being loaded after before seeking for the user 32 DLL. So you can check it easily like that after you understand the static analyzing for it. So it's quite important that for any kind of the shellcode analyzer to know about the statically how the shellcode is actually operate, so they will know exactly about what to aim and what to confirm and stuff like that. And probably just have to aiming for the new modifications or new implementations that not being commonly used or usually spotted or shared in the internet. Then debugging was going. You'll learn about how to seek those in the memory and try to confirm about where exactly the shellcode is located. And then after being executed in this kind of form, it makes you understand about if you are seeing the system that actually being attacked by the shellcode, and the shellcode is more or less is still there in the memory or being safe in the free space during the forensics. Probably you can seek it, and in the carving, then you can know exactly about the location of the those shellcode. So this is quite important, so to understand about what kind of the strings that actually intact. So any kind of the forensics tools like Surrogate Linux or XOAs or ENKs can seek it later on. And this is quite important actually to understand about this kind of the code exists in the memory, in which part of it. So if you are handling with hot forensics, or probably you can aim those kind of part of the memory to be analyzed further with, for example, volatility and so on. Then you'll learn about how to debug that, and to make sure about the understanding about the concept about the how exactly this shellcode is loading. And it's a quite good, nice, and this depends on the looping. It's only a calling for the executable for the executing the message box over here. It has one call, and there is another one here to execute the call library A to load the user 32 DLL. This is quite nice, and this is actually a good challenges for you. So this is about the video 004. It's quite challenging, so we'll go to the next part. In the next part, we are talking about the Linux operations of the static and emulations analyzes for the Linux shellcodes. And for that, you'll have video number 005 that can see in the usual place. Let's switch to the video folder. Okay, here it is. It was 4 before, and then we're going to the number 5. Let's do it. Well, you go to the Surrey Linux for this kind of the operations, and then we are trying to use this example in the radare shared shellcode to be a standard practice of the shellcode in the radare team. So I'm gonna share this to you. These are the shellcode actually copy paste from the radare book. We strongly recommend you to read it if you want to master about the radare, and using this shellcode is quite good. So just disable any kind of the options that you don't need it, and then all you have to do is compile it and doing the analysis afterwards. And it is Surrey Linux that I'm using, and then in this part you have to compile it first. After you compile it, you will seek in the binary itself and to seek where exactly the shellcode is located, and then try to learn about how to aim the after compilations main functions, and then there the shellcode after being found. All you have to do is analyzing the shellcode itself. So this shellcode is not easily being read because of a little bit obfuscated, and it will explain to you about the usage of the IO.cas for the setting environment to not messing with the real binary, but you can make a kind of the modifications with the data that actually you are analyzing. And it's quite good practice for you to understand about how to operate rather with currently intact tools that help you with any kind of the analysis. And these are the data, and then it has some little bit of obfuscation operations in this area. All you have to do is using the commands that being implemented in the radare that we explained before is a WO, and then we can move forward. These are W commands that can help you to manipulate the bytes, and after that you can implement this after being setting the IO.cas into on first. And afterwards, all you have to do is to make sure which part of the binary to be set in the WO command. In this matter, it will teach you how to calculate the stuff that you need to obfuscate or recalculate the structure of the binary that being obfuscated to be easily being read as per program in the shellcode to avoid the direct reading for it. And yes, after you understand about this and implement it to the function just like that and running it to the specific path in the binary, and you will see the actual shellcode as per used to be coded originally. So this is actually the good ways to start the kind of the analysis in the radar way. This is static analysis. Do not get it wrong. All we have to do is just recalculate the stuff and put it into the CAS platforms, and then we can analyze further in the CAS platforms to make the make sure about what kind of the operations are actually being performed. And this is a quite good example. I want you to understand that, helping you about knowing how to seek the with the syscall and so on. And along with reading it, you can also being guided about using another kind of the implemented functions to make a calculations between the number hexadecimals to decimals to octal and so on. That will help you with the analysis. And it's also I will show you how to make a comments, and then how to dump actually the data that being coded in the hex, so can be seen soon and easily with text edit hex editor and text viewer in the radare2. So the sample will actually was using this kind of the command to make a modification for the your password file. So, and the other commands is also interesting. I'm sorry, and the other demonstration is also interesting, which is explaining you another shellcode that can be used also for the Linux platforms. And this shellcode is analyzed also as per before, compiled first, and then after you compile, you don't know exactly what the main address is, and it can be anywhere, and then it should be here, but you don't know exactly where the EBX here in the static analysis, right? So if using the static analysis and you want to know exactly what the EBX is located, you don't have to debug it, but all you have to do is run the emulation, so you will know more or less about the address of a EBX, and it will be demonstrated in this sample. And this is how you start the ASIL, starting the virtual machine, starting to make this position as a base of the tracing, and then the ASIL tracing is started from there. And then in this section you will get the locations here. This is actually the address of the main will be located, and you can go there and make your further analysis. Then afterwards you will be guided in that sample to seek where exactly the shellcode is located. And then if you don't know the address, you can do another ASIL calculations for making sure about the address of the shellcode itself will be known. This is actually the shellcode, and how to deal with the garbled kind of the assemblies. You can fix them like this. It has a very good tips for that, and so on and so on. So down to the direct statically analyze each command, which having what kind of the meanings, and in the end you will see this is actually the bind cell that will execute the cell bin.sh, and it will guide you until the part where actually you can make a demonstrations to connect from the remote for that. It's a very good explanations actually for the Linux shellcode analysis. So this is for the this demonstrations number 5005. So we'll go to the next part. In this part, we go back again to the Windows environment, which now we are talking about the executables in the Windows shellcode. Mostly is using the infamous WinExec API, and WinExec API can be reached with many kind of the ways to avoid the detections, to make sure that we don't know what actually WinExec is called from, and so on. So you have to know certain ways that to make you understand about how to make WinExec being executed in the Windows shellcode environment. So this is the part for that. And for this purpose, we have a plan like this. Very simple. We want to use the WinExec API to execute the calc.exe, the calculator, or shell like a CMD.exe, for example. The plan is easy, just like this, but we want to get to the WinExec in the three ways that commonly being used in the shellcode nowadays. So we will go to the demonstration, first demonstration, second demonstration, and the third demonstration for each of the methods. And for that, it's gonna be back to the basics that we have to remember about the usage of the rwin.cs, the usage of the dump bin, and you have to know about the kernel 32 RVA or kernel based RVAs, and how to make a calling about the APIs, how it is located, and then the naming for that. And After you understand those informations, and then you also refresh about the usage of the stacks, and then how the stacks can put the data back to the register, and how those data in the register can be passed to another function or another loop that being actually called. So register are limited because this is 32 bits, and there are many kind of changing dynamically used values for the register that being used a lot, and so on. Then you have to make sure about that. So firstly, probably in order to get to the kernel libraries, you have to understand also about the PEB, and then goes to the init order and stuff like that. Then after that, you can go in each init module library, like NTDLL, kernel base, and kernel 32s, and then seeking the function that is needed to be run from there. That kind of the information is already explained in the previous videos and explanations. So this is a kind of the implementation for those in order to understand about the execution through the WinExec. The video for that operations is actually here. You can see it, WinExec 1, 2, 3. These are the video number 006, 007, 008. Each of the video is explaining the different implementation of the WinExec. So all you have to do is listening to the presentations about the briefings of each of videos, and then you have to practice by yourself by watching the videos afterwards. Okay, the first method is we are using the video 006. It is a way to, well, after you seek about the PEB and you know exactly what which init order and which kind of library you want to aim, and then you seek the desired API functions and function names strings that being in the kernel's libraries, and then you want to execute the WinExec, and then you want to go to the exit process afterwards. Then in this example, as per seen in this screenshot, you can see that the WinExec, calcexe, and exit process strings are pushed into stack to be used for this purpose. The video is quite simple. I'm going to run it a bit for you. So this is the video. Well, this is actually the video that I want you to see. Well, this is the plan that we were talking about before, and these are actually the data that being used for this practice. It has 3 binaries related to the WinExec, and we doing that one by one. And as you can see there, we manually changed that to the many kind of the formats of the hex that can be used for the template compilations of each shellcode to make sure that is it working or not. Then in the C's and the assembly one, this is assembly one, then all you have to do is compile it. This is the C templates, and then you put it there, and then you have to compile it with explanation that I explained before. And after that, you probably would like to make sure that is it running or not. Well, compilation is as per explained before, and then if you're running it, it runs. Okay, good. So we are having stuff to analyze then. So this is also the test for the after compilations, and the explanations will go with in the radare environments, which is explaining about what kind of these strings are doing there, and then there are some tips of the analyzing through radare for the shellcodes that can be used for you. And I'm making a manual analyzing and making comments together in the screen, so you can follow that in the videos. And then you can make changes, many kind of the stuff in the radare to make it sure it is bright enough for you or good enough for your eyes and stuff like that. Some good coloring scheme are there too. And after being analyzed, you can make a study about the what kind of the operations actually being going on over there. let's go forward. So after the static analysis was done, and we have to learn to analyze that with debugging, and then in the safe environment you can just use the OOD command, and you will go to the you will load it to the memory first, and this is actually the library needed for you to analyze and being used by the application of the Shellcode, and after being compiled, of course, and then after that being loaded, then you can do whatever you want in the analysis, and everything is there for you to see, and I will teach you how to use that kind of the environment to analyze. And these are the video in the fast forward. Then after you get the you can also use the information that you did before, and you put those comments in the specific parts again during the debugging, and then to make you understand about what kind of the operations is actually going on, and in which kind of register, and which register is doing what. And afterwards you can just aim for the stuff that actually can be used for you to confirm whether where is the exactly WinExec. For in this case is gonna be in the AX register, so just confirm that, and I'll show you how. And after that, after this being done, we'll confirm it with some kind of the debugging, and there is supposed to be execution somehow, and after that the program will continues to the exit process and until finished. So the next part, we are going to the second video, which is let's go to the slide first. We are using the other ways, which is using RVA to hash the function to names, seeking with a loop, and then match with a WinExec, and then hash, and then this is a pretty much operation using the hash, just like the message, the second, the mystery file that we analyzed before, and save it to the address to executable register, and then push WinExec arguments, which is cmd show integer, and ucmd line, which is contains of the calc.exe to the stack, and calling to the register to execute WinExec to execute the calc.exe afterwards. So this is the binary that being used for analyzing, and then all you can see is only the calc.exe over there. So you don't know about how it is being used to execute this calc.exe, because of WinExec is not being saved as a string, but we are using the hash operation for that. This hashing as matching stuff is quietly oftenly being used by the Shellcode, so you have to understand this method too. And for this, we're gonna take a look to the video 007. Okay, here we are. All we have to do is execute this. This is only a preview, so I will explain about this video and how it is actually working. 005A sample. It is different with the numbering of the videos, and then this is the binary that's being analyzed here. And using the same methods, you have to make a preparation for the compilations. Let's skip that area, and then after that you have the Shellcode ready and being ready for analysis, and it's becoming the exe file. So making the explanations, but one by one, what it is actually doing, like this. And afterward, I'm going to skip it. It is all over there in your archive directory, so if you want just to look about those comments, just access them, and then you can use that for your own any kind of the purpose that you want to use. And then yes, and we can check about how it works there. As per explained before, it's using the hash and what kind of the hash being used. This is actually the hash part, and actually what kind of the command that being used is written over there. And yes, afterwards the hashes is actually pointing to the WinExec, and the WinExec being executed afterwards by calling the EBPs here. It's quite a straightforward for this analyzing, and it doesn't have the quit command, so I'm not sure is it gonna be a very good way to do the coding though, but it's working. And further, it's about the debugging. So we are doing the debugging process too after it is being compiled and being statically analyzed, and we know more or less about how it works. And it is explaining with many kind of the help that I wrote under that. If having some kind of the explanations, it will help you to understand the videos after you seeing it. So it's quite easy for you to follow, and you don't have to deal with my voice also. And after that, this is the debugging guidance that will help you through the debugging process, and then will lead you about how to make sure about which kind of the calculations of the register. And another sample also being performed here. Two samples is being actually analyzed in the same time. And yes, the same way of the analyzing is being performed, different samples. And after that, this part is finished. And in this presentation video, you'll be expected to know about the WinExec executions, and there is another part of it which is will be explained in the video 008. In the video 008, you will have another ways to execute the something with a WinExec. In this way, I'm going to execute the CMD's, not called XA, but CMD's XA, a cell. And for that, the plan is still same, like we're going to use the WinExec to run the CMD, but through another workaround. Well, first we load the kernel modules, and then go to the init memory order and find the kernels 32 DLL, and using the module name hash matching, we are gonna put the desired naming functions into the memory, and matching it through the name table in each of the library that being loaded according to the init mem order. And we'll seek the get proc address, this mistype, and save it in the EDX, and we'll push the WinExec CMD and exit process to the stack for that kind of operations. And we'll use the get proc address to run WinExec, and to run for that WinExec to run the CMDs, and then afterward we'll do the exit process. We're not going to run this over here because of this kind of boring. It's the same kind of the process that you saw before. So we're going to skip that demonstration in this video, but the video is there, so you can see it here. Okay, I have to kill first the previous videos here, and here it is. If you run it, this is actually the one that I mentioned before. The size is a little bit weird, but is there. So it goes like this. It has many kind of the analysis and so on, just like before. And in the end will lead you to the debugging here, and afterwards you will be guided for the executions of this calc after being executed. And there are some trials and error over there, and then many interesting things that you can confirm through the debugging process and so on. Same as before, the telop will be there for my typings, explaining about the process that for you needed to be going through. So in here you can understand about what's going on with each call or name table being used. This is stuff that actually can be confirmed in the memories, and many kind of the guidance is needed, and then execute it again, and also how to use the there. In this part is we are trying to use Arwin again in order to get to know about the get proc address after being sick. So after the process being sick is it will show exactly the pointer to the absolute address, which is not being used, but can be used for confirming whether the API that being sick is actually being found. So if we can compare the result of the Arwin.cs for such API in the certain libraries, and then compare it with the value of the pointed or saved register for that API, and we can actually checking whether the shellcode is actually match the desired functions. That's a quite important concept that are being introduced there. And after matching, it will show a lot of stuff. So I'm gonna fast forward this. The next is we try to understand about the modular concept of the shellcodes. It is provided with a example. The example file name is second007, but the video name is different. The video name is video 009. So yeah, this is actually the modular shellcode. In this example, I'm using it. I'm using the downloader. Yeah, we try with the executing something. We try with popping some message boxes, and probably the most interesting things to learn in the basic one is downloader, right? So if you want to download something and to run it, probably you will need a shellcode, and if you need to know how the shellcode will work for that, this is an example for you. And yeah, the concept is quite the same. So first is you have to prepare the functions, which is looking into the init memory order to get any initial kernel libraries needed, for example kernel 32DL or kernel base DL, whatever. And you can seek another method to seek, which is using the Unicode module name length matching to the some bytes values. And this is a quite secure for seeking for the module name, not only matching for the strings, but you have to make sure about the lengths in the Unicode module name. And after you get the actual module name, either gonna be a kernel 32 DLL or kernel base DLL, and you can load the data needed for the CMDs and the URL where you want to save the payload into the stack, and you can use the load library A and URL download to file A, winexec exit process, and get the base address by hash matching functions for each of these APIs. And you can use simultaneously load the library A to load the URL mon DLL to execute the URL, download to file A to, and finally you will use the WinExec to execute Notepad to view the payload, which is a text file, and then exit. It's a quite neat scheme. So this is the binary, so you can see the notepad is there, the whatever the name is in there too, and such kind of a URL is there, but you don't know what's going on, right? So this is actually the shellcode for that. It's not that big, it's around this size, so it's quite easy to understand. So the video is in the 009, but before we do the analyzing for the modular shellcode, which is quite complex operations, since register in the 32 bits is not that much, so but you have to understand about the stack frames, high and low addresses, especially related to the arguments that being used for the passing to one and into another functions. And if you are in here in this stack frame, so this is actually the old base pointer is having about this kind of the variables with this kind of the size. These are actually the basis, and then sometimes we are dealing with the stacks. You have to know exactly also about the high address and low address, that possibly the range of the stuff that can be actually being saved or operated temporary in the memory for the analysis purpose too. And for checking out of the which kind of the API being used for in each of the module name module that being loaded, for example, again kernel 32 DLL or kernel based DLL, you have to understand about this offset of the library file itself, and which offset address, and then what kind of the virtual memories that actually can be calculated to each from the each points, and then you have to know this to in order to understand where the export table is and how to get to the address table, for example, after that, and go to the name pointer table and ordinal table. After you know about the ordinal number, it's not so hard to get the function matching, function name matching, and put this function address into the memory, and making a register to point to that function address too. This is actually the base that has to be mastered, both of them, if you are gonna deal with the modular shellcode. So example that we done before about the previous analysis that can be used as a reference of before we starting doing the modular, because of this actually a bit of the modular that was teaching you about the using get proc address to run the API under another libraries. So you don't have to necessarily load library first and then you seek it again through that memory, but you can use this kind of the process, this kind of the concept too. And yeah, go to the demonstration afterwards. So I'm gonna switch to video, start with the explanations, and then go to the basic first, different with the previous one. Probably some of you are wondering why we have to go to the PEB. What is PEB exactly, for example, and why is it stuff that we need to know? So there are informations about that in the Wikipedias that you can understand about those kind of the operations. It has TIBs here, which is explaining you about the threat information block, and through the pointer of the part of the TIB, there is a pointer that leads you to the PEB one, and over there is an explanation for that, and these are the concepts that making you to understand about how to count each pointer and each address after one to another. in order to get the REV table and go to the further details after that. Well, this is a know-how that being added before starting the demonstration for this matter, and it will explaining you again about this stuff, just to make sure that you have to understand those. And here we go. There is a sample for that. All you have to do is analyze that sample, reproduce it, and then try to, well, you are a little bit professional right now, so let's run it and testing whether it is working or not. And after you execute it, it will download and execute the notepad and showing it, and these are the files that being downloaded. It is a URL that making you access to your own local host. So all you have to do is try to run HFS exe that is provided in the examples or toolings folder, and put the s.con file inside of it, and running it before you start this practice. So it will download and just popping up the s.con text file into consoles with notepad, and it will be saved in your default directory where the Shellcode is actually running. It's very safe. It's not malicious or anything. It is used for the making you understanding about how to download something through the Shellcodes, and then how we can making ourselves understand and making mitigation and analysis accordingly. Then we have to analyze that, well, as usual. Then it has a style of explanations also, so you don't have to be worried about not knowing about what I was talking about in the middle of the video. And there are plenty of the comment that you can see, and I really like to analyze the stuff thoroughly, so you can see in the very details. So this is actually quite a good many kind of the comment actually being implemented here, so you can see it there. And after that, these are actually the result, which kind of the module that actually being exists here. And in this part, it is also introduce you about how to analyze the modular binaries, modular Shellcode binaries, which helping you to operate faster, and it will you will be explained about the how to use the flag, how to go back from the previous operations, to how to use the visual mode of the radare, not only with the command line as per the beginning of the analysis that we are doing, and then several good tips with the visual mode will be introduced over there, and then how to change the name of the functions, and then how to make data can be shown as a text or can be treated as a kind of the definitions with the opcodes and so on. So these are the results. So practically it's already analyzed by me for you, so you can just follow this video and doing it by yourself, and you will see about the what kind of the result. Comparing the result is pretty good too. This is actually the analysis result showing in the screen being dumped into the text file. We have explained this before too, so it's gonna be like this. So you will not losing the records after analyzing something. So it is actually making you more understand about how actually one Shellcode is working, and then after you understand this Shellcode is working this way, probably you will have a very sharp confirmation points to do while you are debugging it further in the dynamic analysis. These are actually the part that the key points that you need to confirm, and then they are quite probably not a straightforward kind of the executions for the modular basis cell code. It will call here and go back there, and after calling it will return it such kind of value in the some register, and then you have to make sure about that, and then after understanding that well, you can make a flow simplified like this. So actually this is how the shellcode is working, and then after understanding this, you can go to the debug based on this kind of the flow that how the shellcode is actually operated. So it's much more simpler to understand for you. This is the way I'm doing it in many kind of the analysis until now for the shellcode. So this is a way to do it, and then after that you're going to the debugging. Debugging is also the same. So going to the memory, you'll find many stuff over there. Go back to the analysis path that you already dumped it before, and then you go back to the binaries, and you will see some of the result, and go back to the basic again to understand about which kind of the to confirm which kind of register are using by saving this kind of the values and stuff like that, in order to understand the flow better. Then many kind of the telop is also being made by me, so you will not being lost. Don't worry about that. And after that, how to use some breakpoints to confirm some stuff. So this is about how we need the WinExec operations, and then this is after being executed and so on. So it's gonna be there, and this is actually a quite good exercise for you to understand about how it is close to the reality, where most of the shellcode nowadays are actually being built through the builders, and these builders is actually making modular separate between the one module to another, so you can make any kind of purpose, just put them into some modules and compile it to one binaries and so on. So you will get used to the closer to the operational mode for analyzing shellcode with this kind of concept, with this concept of analyzing shellcode in modular stage. If you have interested with this kind of shellcode, I have many of them, so probably just contact me in the Slack for that. Remember, we're here to learn to dissect the shellcode, and we are not allowed to use the shellcode for the malicious activities, and that is not the purpose. I'm here and you're here, and we learn together to make our world safer. So we go to the next part after this. We continue with next sessions, which will go to the 64-bit shellcode.